Good afternoon, everybody. My name is Phillip Wilfert. I am a postdoc researcher at the Technical University of Delft. And I would like to present to you our biorefinery approach for recovering resources from aerobic granular sludge. We work on this subject together with our academic and industrial partners in the frame of the water mining project. Just a few words on the water mining project. It's an EU-funded project with around 38 partners, mainly from Europe, but also beyond. Overall project coordination is by TU Delft, and the total project budget around 20 million euros. We started last September and will continue working for the next 4 years. It is funded under the Horizon 2020 program, and the focus is on resource recovery technologies, and there a further focus is on sewage treatment and desalination. And I will present you in the following some work of a work package that deals with aerobic granular sludge and resource recovery from aerobic granular sludge. Just a few words on granular sludge for wastewater treatment plant in general. I assumed you are more or less familiar with it. Well, as the name says, you make use of aerobic granules. That allows you, because the sludge settles quite quick, that allows you to make use of basically a single reactor, and your wastewater treatment plant, the physical footprint can be really drastically reduced. Here on the picture, you see the wastewater treatment plant of Groningen. On the left-hand side, you see the old facilities, and the new granular sludge treatment plant treats the same amount of wastewater than the old part, highlighted here in red. So to sum that up, the granular sludge for wastewater treatment allows you to have treatment plants with a very small environmental and physical footprint. The treatment is very efficient, so I think it's clear that it's a very economic way of treating your wastewater. But granular sludge systems have one additional benefit. If you zoom in the granules, you will see that they actually consist of bacteria and biopolymers. The biopolymers, or extrapolymeric substances, are excreted by the bacteria. They form or act as a kind of a glue to allow the formation of these granules. And this biopolymer can be extracted, and it is currently marketed under the name Kaumera Nereda Gum. Now, if you look at this Kaumera, of course, it's clear that it's a biodegradable and fully sustainable polymer because it comes from wastewater. But it has also really unique features that make Kaumera special, and therefore also allow to produce unique products out of it. So for instance, in very near future, and it has actually been proven that Kaumera works as a biostimulant, so it stimulates the growth of roots and plants themselves. And it can be used as a fertilizer coating to control the release, the slow release of nutrients into the soil. And that is, for instance, currently being done with polyacrylamide-based materials. In very near future, we foresee a lot of high-value applications. So for instance, Kaumera is biocomposite to produce such medium density fiber blades, for instance. And on top of that, as an add-on, Kaumera has already been shown to have really impressive flame retardant capacities. So to sum this up, and to keep in mind, the Kaumera is really the starting point of all other resource recoveries I will explain you in the next few slides. So this has always priority. And sitting here in Delft and giving my presentation at least a bit of an Italian flavor, I called Kaumera numero uno, but you can really remember that this is the star of our resource recovery facility. How can the other resources be recovered? For this, I need to briefly explain you the Kaumera extraction process. So you start with your excess granular sludge, you increase the temperature and the pH, and at this condition, Kaumera goes in solution. And you do, after this step, a solid liquid separation. you end up with a sludge residual, sludge pellet that is currently considered as waste. Your Kaumera in solution goes to a next tank. And here you decrease the pH, your Kaumera becomes insoluble, and you can have in another solid liquid separation step, separation into your product, Kaumera, and you end up with a liquid waste centrate, which is acidic. Now the first waste stream, this residual sludge that you yield here in the first separation step, that is actually a thermal alkaline pre-treated material. So it's mainly organics, and it has been exposed to high temperature, high pH. So this usually improves the methane formation in anaerobic digesters. But here we are at a high pH, and we have a high salt concentration due to the salt that we added to increase the pH. And here it invites to use a process called alkaline fermentation. So it's basically an anaerobic digestion at high pH and high salt concentration. And this has the benefit that your fermenter acts as a kind of a CO2 scrubber. So you form methane and CO2 biogas, but your CO2 remains in solution and only the methane goes into the gas phase. So you produce a very pure methane stream that can be directly used as a substitute for natural gas. And in experiments at TU Delft, we obtained a stream which was 95% pure methane. And here we make use of special microorganisms that occur in soda lakes with a high pH, high carbonate alkalinity, and high salt concentration. Let's go further. Another stream which is attractive for resource recovery is this as alkaline centrate after the decanter. It has a very high temperature and pH, and the high pH invites for phosphorus recovery. At high pH, it should be doable to add calcium and to obtain calcium phosphate crystals. And these phosphorus crystals, calcium phosphate crystals, should be or are directly usable by the fertilizer industry, because calcium phosphate is basically phosphate rock, the material that these plants anyway use for fertilizer production. The high temperature in combination with the high pH invites for nitrogen stripping technologies to recover nitrogen. They are on the market, they are commercialized, but usually they are not attractive because you have to increase the temperature and the pH. You have to invest a lot of chemicals and energy. But here we have already these conditions. Now, what are we doing? We take this whole Kaumera extraction process. There are, by the way, already 2 pilot installations in the Netherlands. And we shrink it into a container to make it transportable. We add on a bench scale different technologies to recover not only the polymer itself, Kaumera itself, but also methane, phosphorus, and nitrogen. And then we go on the road with it. We first test the installation in the Netherlands and then bring it also to Faro in Portugal to see if it works on different wastewater facilities. On top of the technological aspects, we also work with our partners in the water mining project to boost the commercialization, not only of the products, but also of the technologies themselves. We focus in the water mining project on the agricultural applications of Kaumera in Portugal. And we have, for instance, people that work related to policy, and they identify enablers and barriers for Kaumera commercialization. For instance, they found in Portugal that sludge application on fields is allowed on agricultural fields, but for Kaumera you would require an additional permit. which is not logical because Kaumera is free of pathogens, depleted in heavy metals, but still you would need another permission for it. It's not a showstopper, but it shows that there are sometimes legislation or political aspects that make our life more difficult. We have people that look at the economics because probably we would need new business models when your wastewater treatment plants in future will not only treat wastewater, but also produce very valuable resources that can be sold. And this will also change some social aspects, because now your wastewater treatment plants produce locally very valuable resources that can also result in chains that produce more high value products there. And of course, we do on top of that life cycle assessments, look what is the environmental impact of our technologies. I would like to take you home that we have in our activities in the water mining project and more detailed on the resource recovery from granular sludge. We have an engineering part where we build and operate an installation to extract Kaumera from granular sludge. We have some research going on the bench scale where we investigate technologies to produce pure methane using alkaline digestion and nitrogen and phosphorus recovery. And these we are testing at the moment and will add on to the Kaumera extraction in future. And we have different activities going on related to the commercialization of Kaumera and the related extraction technologies, where we look in environmental, economic, social, and political aspects to improve the commercialization of these products and technologies. And with this, I would like to end my presentation. I would like to thank you for your attention and our project partners, and I'm very happy to receive questions. Many thanks.